Here's another problem looking at normal distributions. We're looking at some readings of thermometers. They're normally distributed. That normal distribution has a mean of 0 and a standard deviation of 1. So interestingly enough, this happens to be a standard normal distribution. The thermometer is randomly selected and tested. Find the probability of each of the following readings. Okay, so let's look at this this first one. We want a reading between 0 and 0.66. So in this particular distribution, we know that this mean happens to be 0 and the standard deviation happens to be 1. So if we're looking from 0, that's right there at the mean, interestingly enough, and we're going up to 0.6, so it's up here somewhere. Okay, so this is 0 and this is 0.66. Now notice what they're telling us here, or what the x values or the z values are, and we want to find this particular area. Now the nice thing is that R has some functions that will find areas for us. They're called the probability function for a normal distribution. So we're going to look at the probability function of a normal distribution. If I look at 0.66 in a distribution that has a mean of 0 and a standard deviation of 1, that's not quite the answer that we're looking for. I just want to calculate it here for a minute so that we can look and see what we're looking for. What that does find is this. It looks at this 0.66 and finds this entire area over here, okay, which is too much. We need to have less than that. Notice that that part to the left of 0 is 1/2, so we need to have whatever that area is minus 0.5. We're going to do that on the calculator here in a minute. What we're interested in finding then is this area over here that we know happens to be 0.5 because it's everything to the left of the mean in a normal distribution. But let's just do that with R real quickly. See, if I looked at the pnorm, the probability that we're to the left of 0 in a mean that's equal to 0 and a standard deviation that's equal to 1, and of course that's 0.5. We knew that already. So it becomes easy to do this. We just find the probability of being left of the largest number minus the probability norm of being to the left of the smaller number in a mean of 0 and a standard deviation equal to 1. Okay, so that's going to be the answer that we're looking for. We can copy that and paste it in up here. And let's see if it'll allow us to check our answers. Yeah, sure. Okay, so similarly, you can argue the same kinds of things. Let's just look at the picture real quickly on at least another one of these. In this second one, we've got a standard normal distribution again, the same setting that we had before, but now we want to be between a minus 2.44 and then we want to go up until we get to 0. So we're looking for that area. Okay, now we know that because the mean happens to be 0, we know half of the population is to the left of that. So all of this to the left is 0.5. All that I'd need to do is find this little piece of red area over here and subtract it from 0.5. So using R again, I know that first one is 0.5. I could calculate it with the pnorm as well, but minus the pnorm of, see if I can arrange this so that we can see that, of a negative 2.44 in a distribution whose mean is 0 and standard deviation is equal to 1. Okay, so there's the answer that we're looking for right there. I can copy that and paste it into here. And let's check our answer. There we go. Okay. Now these others are a little bit more interesting. See, let's look at this one just real quickly. I think I can possibly slide that up just a little bit so we can see it better. Okay, here we want to go from a negative 2.27 up until we get to a positive 1.79. Again, my mean is 0 and my standard deviation is 1. So let's get our picture of our normal distribution here. So we're looking at this, again, a normal distribution with the mean of 0 and a standard deviation of 1. We want to be over here, quite a ways over here, at a negative 2.27. Sorry, this is a negative 2.27. And we want to go up to a 1.79. So what we're going to do is find the area to the left of this, which will be too much because it goes back here in this tail as well. And then we're going to come back and find this tail, this area down here in this pink part, and subtract it. Okay, so let's move this up so that we can see it. So we're going to do the following. We'll look at the probability in a normal distribution to the left of 1.79, and the mean happens to be 0 and the standard deviation happens to be 1. Okay, that's too much, minus the pnorm of negative 2.27 in a mean of 0 and a standard deviation equal to 1. The powerful thing is that this pnorm just tells us the area to the left of whatever we put here in the first argument, and then we just need to tell it what the mean and standard deviations are. So there's the answer that we're needing for that one. We can edit that, and I believe it was right here. We can paste that in and check our answers. Okay, hope that helps. Good luck on the rest of them.